Well, after that wonderful introduction, welcome to SkyTour LiveStream. It's really nice to, be able to do a stream. We haven't had much clear sky lately, but now we have a little bit more. So here we are. I hope you guys are in for a while. The sky is not perfect, not just because of the moon, but because of the fact that we have some clouds around, and we're gonna try and work around the clouds as best we can. It's really nice to see you here. Some of you that have already showed up. Dalai's here, Evan's here, and Watch Show TV is here along with John McKitchney. Hey guys, and Andy Morrow. Nice to see you guys out there. You are the early birds, especially Andy. I think you're over in the UK, aren't you? You're really an early bird. But anyway, I will be showing you the moon tonight and a few clusters that are out. There's some things that are near the moon. And I'm running it alone right now because Daryl Mason's not with us at the moment. He may join us later, as well as Amanda. She suggested she could show up a little bit later, possibly. But it's fine, because I ran it alone from the beginning. And I was perfectly okay with that. And so that said, I just wanted to share with you some of the stuff that's going on this end of the world. Plans are on track to move this entire observatory to Arizona in the coming year, actually. I'm going out there in 2 weeks, and I'll be out there from the 24th of June to the 1st of July. So I should have a lot of time to actually spend looking for some land, and courtesy of Marianne, who is just in the chat there, Marianne Robb. She is helping me locate places out in Arizona. She is a police officer in Arizona, and so I kind of get a nice royal treatment from her. I get to meet a lot of cool people out there. I have more friends in Arizona, I think, than I do in Connecticut, where I live, which is really amazing. So I'll be out there from the 24th to the 1st. I'll be doing talks in Sedona, and I'll be doing a talk in Show Low, which is another town in Arizona. Arizona has great names for towns. I mean, any state that has a town named Tombstone is on my list. Okay, very, very cool. Anyway, I'm pretty sure that when they go out there, we'll have a lot of fun, a lot of things to do. Currently, we're looking at the moon, as you can see, of course. And whenever I look at the moon, I basically have to think about how much the moon is such a part of our culture and history, from the way the Earth formed to the life forms that exist here on the Earth, all the way to the way in which we have formed religious beliefs and spent time figuring out day and night cycles, all related to that little guy up in the sky. Not so little, a couple thousand miles across, but I'll tell you, it's really something. And I have to say, the moon has another fascination. When you look at the near side here, we see the light and dark areas. Of course, the dark areas we call Maria, that is seas, quote unquote, and they're not really seas, but they're just plains where lava overspread the area from larger impacts. And you can actually see that on that part of the moon where you actually see these impacts, they tend to be round like this because, of course, these were the round impacts that struck the moon. And they went so deep that they actually caused the lava inside the moon at the time, because it was mostly molten just below the surface, to overspread onto the surface. But if you zoomed in on these, using the Lunar Reconnaissance Orbiter Quick Map, you find that those flat plains that look like really flat plains on the moon are actually pockmarked with millions, not hundreds, not thousands, not hundreds of thousands, millions of craters. And the craters sometimes have craters within them. In all these tiny, tiny craters. You literally can't find an area on the moon that doesn't have an abundance of craters that make it impossible not to step in one as you walk across the surface of the moon. So it's been around for a long time. It's been subject to bombardment. Early in our history, we had the early bombardment era, and there was a a number of bombardment eras that we went through here, actually. And the moon was actually just an amazing catch-all for the meteors, but you got to keep in mind, it also has its own gravity. So the moon was also pulling objects out in space toward us. And that's kind of a big problem as well, because that means that the Earth was a target also with the moon for the objects that the moon helped bring toward our area of the solar system. So when people say, well, the moon saved us from being hit by other things, did it? It's possible that the moon caused us to be hit by other things. So it's out there swinging around in a wide orbit, 240,000 miles in radius from the Earth, going on either side of the Earth. And that stands as a large galactic gravity sentinel out there that's pulling objects toward it, and maybe eventually pulling them toward the Earth so that the Earth could get bombed by these things. Yesterday I was looking at a Google Earth layout. I really recommend you do this. Google Earth has an overlay that has all of the impacts on the Earth, many of which are visible now. You can still see them. And there's not 20, there's not 50, there's hundreds and hundreds of impacts visible on the Earth right now. And there's a database you can go add to your Google Earth as an overlay. And this would really, really be amazing to do that, because then you'll see just how many impacts there are. And you can zoom right in, and when you click on them, you will get the information about the diameter and other data about the impact and approximately how old it is. And you'll find it's quite amazing that the Earth has been hit throughout its history many times. Most people think, well, we had the asteroid strike and the dinosaurs were rendered extinct. Yeah, that was 65 million years ago. But what about in modern times? What about in the past 30,000, 50,000, 80,000, 150,000 years? You know, well, most people will say, well, in Arizona, there's the meteor crater, also known as the Barringer meteorite crater out in Arizona. That's east of Flagstaff. And people say, well, there was that one. It's like, that's not the only one. There were thousands upon thousands more. And they're all cataloged in this Google Earth overlay that I think you guys should get and check it out. That's pretty cool to look at when you look at all these impacts. And like I said, many of them are on the surface. You can see them. They haven't been destroyed by erosion yet. Some have formed lakes. Okay. Some have formed strange mountain ridges. Some have been destroyed by some erosion, and all you see is the crater rims, and the centers are all filled in with sediment. But boy, oh boy, you got to check it out. It's really, really neat. So I think that is really a neat thing you guys ought to check out. All right. So with that said, I just want to close in on something here and just check it out. I'm just doing a little bit of moving around here. Our telescope is not one that is designed for doing a lot of lunar views. The camera is not the best camera for lunar views, but we are looking at the moon right now. I'm just doing a little focus view here at night right now to check it out. And I think that, believe it or not, we actually have some pretty good focus when you look at these objects here. They actually have some fairly sharp focus. And for proof of that, we'll take a picture. All right, and to do that, I'll just do this right now. So here we are. I'll move it back to where we can get a better view of it. All right, and we're going to move east a little bit. So here we go. So now we're going to take a picture. It'll be a 45th of a second at 50 ASA. That's the sensitivity. All right, so let's see what that looks like real quick. Okay. All right, so here is the image. We actually have some high clouds in the area, and we also have wind, and wind has caused this image to be a little bit blurred. Earlier images that I took have come out a little better. So let's go check it out. Let's go back and see if we can do a little better than that, shall we? Yes, we shall. Let's do this. Let's go a little longer. Actually, no, I want to go a little shorter. Go 200th, and we'll up the ASA a little to brighten it up. Okay. And let's just look at the focusing view one more time. Yeah, that's okay. All right, and now let's go back and take the picture. 200th, and let's see what we got. There we go. Well, yeah, the high clouds cause a little bit of a distortion. We're kind of looking at it a little bit through high clouds. So that is something that we have to deal with. Yep. Anyway, I guess we will just deal with it, you know? Hey, there's Daryl. Hi, Daryl. How you doing? I see DW is here. Good to see you guys. Daryl got himself a telescope, guys. Oh, yes. And a really nice one, too. Leave it to him to outdo SkyTour LiveStream. Let me tell you. But it's okay. I think that what he got was a really nice telescope. And if we get him in tonight, he'll tell you about it. Okay, so I'm getting my cameras back in the dome. Maybe we'll check out Jupiter later. I looked at it yesterday and it was not, didn't have the red spot showing. It was on the other side of the planet at the time. So we didn't get to see it. But that's okay. All right, so let's see now. We got this view here. This view here. Okay, that's our live view. And let's do this. And this and that. There we go. All right, so that's beautiful. And let me just drop this down a little bit. Okay, and let me check it out. Yeah, it's looking okay. For what it is, I should say. Yeah, okay. Let me just bring in Daryl here. Here we go. Yay! All those awful sounds from Skype. Okay, not yet, but soon enough. He's like, oops. All right, not a problem. He needs a minute. So, that's fair. That's okay. Tonight, you know, like I said, we'll take a look at Jupiter in a little while. While I'm here, actually, I am going to do some critical focusing as well. I did this before, but I'm going to do it again, because as the temperature changes, the focus will change as well. So there we go. So now let me... Okay. That looks a little better, actually. Let's take another picture. Here we go. Now let's see what we got. Oh yeah, look at that. See that? Temperature makes a huge difference. See how much better it looks? That's very common. Very common for this to happen. Alright, now let's see here. Okay, I'm gonna give Daryl a call right now and he'll be joining us in a second. And there he is.
Hello.
Hey, how you doing, Daryl?
Hi, Mark. How you doing?
Good, good, my friend. I am here having a good time so far. I got this picture I just took of the moon. What's really neat is you can actually see the colors. You know, you see the different colors in the moon, and I think that's something that is so important for people to understand. It's not just gray, you know? And
Sure.
I love it. Anyway, I know you just come on and whacking it with that. But look at the different colors. Okay, this is clearly a distinctly different color.
Yeah.
I think I need to also make sure I share my screen with you here. So let me do that, okay?
Yeah. The colors on the moon, when you see them, they're usually very subdued. I've seen some really deep exposures, and you'd be amazed how much the colors pop out, representing different elements or compounds, I guess.
Yes, sorry, I'm just looking at the, trying to get my, there we go. I want to get you the right screen. Whoops. And I gotta do it again. Because I have to also share system sounds here. So we got this one. Okay. Now you should be all connected up and you should be able to hear everything going on, see everything going on.
I do.
And you should be able to hear the music that's going in the background as well.
There it is.
There you go. All right. Well, there we go. Yeah,
Super.
so I just like these big glorious panoramas of the moon are just something else, you know. And I love looking at these sometimes because they're just so interesting. Just so very interesting. Yeah, let me see here.
I love looking at the moon.
Do you?
Yeah. Saw Batman in a crater one night.
Did you really?
Yeah, we were doing a public star party, the astronomy club.
Yeah.
And I was there. I had my refractor set up.
Okay.
And, there was a partly lit moon, and darned if, the shadows down in the bottom of the crater, it looked just like the Batman, like the bat signal. Or
Wow, that's
something,
funny.
It was really cool.
Wow. I have never, I know that there have been some strange views of the moon, strange things that we can see in the moon. And there's actually a database of the really odd things that you can see depending on the how many days old the moon is, as we call it, and so forth. And it's really kind of a really cool, it's actually a very cool thing. And I like being able to look at these objects and see what's going on the moon like that.
Sure. Yeah, I've seen a couple talked about just recently. I'm no expert on these things, but at a certain phase of the moon, about a week ago, maybe, or less than a week, there's a crater up there that looks like it has a handle on it. Looks like a suitcase handle.
Wow.
On the rim of the crater. Really jumps out at you.
Well, I'm sure it really is a suitcase handle, and I'm sure the moon's just an illusion.
Uh-huh.
And you know that's certainly the farthest thing from my mind.
Yeah.
Yeah. So then, so tonight, Daryl, we've actually got a few other things. I was thinking of where we might go to check things out, and we've got a number of places we can go. Here is our view here right now, and let's see. This is we have a really nice. Looking here to see where we are here. Just get my bearings here. Yeah, that's not what we want with this. Okay, so we're sitting right now looking at the moon over here, and the moon is in the southwest, as we can see. And we have a full sky coming of objects for the summer that we will see. And we all
looky there.
Yeah, they're heading this way. You know, and we have clusters. We have globular clusters, and we have an awful lot of really interesting stuff. Now, for what we're looking at, I mean, we're looking at, obviously, Ophiuchus. We're looking at Scorpius. We're looking at Sagittarius way down there, and the moon right now you can see here is in Virgo, and we see Spica, which is the brightest star in Virgo, and without any assistance, basically it just looks like a bunch of stars in the sky, which is fine. And our little planetarium program is really cool because it shows the brightness of the sun of the stars relative to the moon, so you don't see a lot of starlight until the moon is out of the view. And then when the moon gets out of the view, watch what happens. See that? Now the faint stars come in. You know, but when the moon comes into view, it washes out the stars, just like in real life. That's kind of why I picked this one to use. So I think it was really quite a good one. You know?
Uh-huh.
Yep.
Oh,
So-
it's that time of year. Golly. You know, the spring stars are still up there. I mentioned Sunday night that Leo is now west of overhead by dark.
That's correct.
And the Big Dipper, Ursa Major, is also getting there. Spica was east of overhead at dark, but it's rapidly moving on. Well, you can see you're 2 hours ahead of me, and it's getting into the southwest already.
Yeah, and here is Leo, the lion, right here. You can see Leo is all the way down toward the western horizon. Now, of course, it is 9:53 here. Okay, 21 hours, 53 minutes. And you can see that it is definitely already down there. But it was right about here earlier. And it rotates this way through the sky. If we want to see where it goes, well, all we have to do is bring up the actual the lines. Okay, so and let me see what I just put them down. So you can actually see this is the horizon lines. Okay, but the right ascension declination, it's actually a I have to figure out where those lines are. I can't remember how I show those here. But I'll find those. But the neat thing is that it's going from obviously east to west, and you know Leo is looking straight up and down at us. You know it's right overhead here, right around sunset. It's just about here, and it's moving toward the west progressively, of course, as the night goes on. And the moon being in Virgo right here is heading eastward each day of the month. So here's the phase of the moon, and of course that is consistent with what we see here in our view. Okay, not quite this view, but if I come back and look at our regular view, you can see that this is exactly the phase of the moon right now that we see. So it's really quite nice that our planetarium program aligns very well with what we see here. You know?
Boy, it really does, doesn't it?
It does indeed. Yeah.
I mean, phase and angle and everything.
Yep. It has all of it, and that's what I like about that program. It's really quite efficient. Anyway.
Mark, can you hold right there for just a second?
Sure, go ahead.
Yeah, if you look at that long, jiggly line down there across the southwest, that's Hydra the water snake we talked about a while back.
Yep.
And then those two objects down to the lower right of Virgo, the one looks like a cup. Well, it is a cup. It's called Crater the Cup right there where my pointer is, which you can't see. Yeah, that's Crater the Cup. And then the little oblong 4-star asterism there, or constellation, that's Corvus the Crow. That's a crow right there.
Yep.
There's the crow.
Yep, that's right. That's good. And then we have next to it, which is seemingly a very small constellation. This is Sextans, I believe.
Right. Sextans, Sextans? I thought that was summer sky, or fall sky. I'd have to look that one up. I don't remember.
Okay.
Sure looks like a sextant or something.
Yeah, it looks like a sextant to me. Well, let's take a look here. If we look at the star, see, it's sextants. Yeah. Yep, that's correct. And yes, I know it says sex, but that's because that's the abbreviation for sextans. SEXTANS.
You make it whatever you want.
Well, it is what it is.
Yeah. There are some cool galaxies in sextants, if I remember correctly.
Oh yeah, I'm sure.
What was I thinking of? I'm thinking of something over in the fall sky.
That's okay. You're probably thinking of Serpens Caput or something.
I think I was thinking farther east.
Okay.
Yep, that sure is a sextant, all right.
Yep. So
You said innocently.
Yeah, right. Yeah. So yes, there's plenty of objects to look at in the sky. And we have our deep sky objects set on right now. So if I turn them off, they just go away. But if they come on, you can see them. And there's a nice little globular cluster here, NGC 5634, also known as MELOT 126. Okay, and this is a globular cluster as well. And it's basically one of these globulars that's what we call a halo object. It's actually in the halo of the galaxy, and it basically will come through the disk of the galaxy every so often and either be stripped of a few stars or gain a few stars and take them out with it as it comes through. And so some of them are far enough out so that they don't really ever interact too much with too many stars in the disk of the galaxy. But the ones that are closer to the center of the galaxy, in their orbit, I should say, will actually interact with the stars in the disk as well. And they can be responsible for some of the weird things we've seen in the past, like stars that appear to be racing out of our galaxy and so forth. But
that's what made me think about that 12 billion year old star that and/or planet, I think it was. You talked about Sunday night.
Yeah, that's right, on SkyTour Radio.
Yeah, if it was so old, maybe it was stripped from a globular cluster. But as you say, globular stars, population 2 stars, tend to be very poor in metals.
Yeah, metals being anything other than hydrogen and helium. Us astronomers are weird, folks. That's the whole thing. We're very strange. Hydrogen and helium are non-metals, and everything else is what we call a metal. Now, that's a little strange, I know, but it has to do with the abundance of the original elements in the universe, hydrogen being predominant, helium being also predominant. Carbon is actually fairly high up there on the list of dominance in terms of its relative abundance, I should say, in the universe. And carbon has the most incredible capability to bond with many, many different elements and atoms. Okay, so carbon is what they call the granddaddy of all atoms. It can actually bond with more things than any other element in the periodic table. And that's why carbon-based life, like here on Earth, isn't such a big deal. In other words, I should say it's a big deal, but I should say it's actually one of the more incredible things that we see in the universe, because carbon-based life is something that occurs sort of naturally. In other words, the universe has created this little template for this carbon-based life, and that's the thing that's really cool. So that's where this is the universe in which we live. So when we look for worlds elsewhere other than the one we're on, we look for other life that might be carbon-based life, just like us. And the reason is because we're rare. The reason is because we are probably not rare. And the reason for that is that all of the elements from which we are made and from which DNA is made seem to have been provided by the fusion reactions in the cores of stars, and by the fact that the universe has a seemingly predisposition to putting carbon-based compounds into play in solar systems. So, carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. And that's CHOMPS, CHONPS. This is the foundational chemistry within DNA, and it's something that the universe provides as a template to all life on Earth. And so every single thing on this planet is based on CHOMPS. Every single life form, even the ones at the bottom of the ocean that do chemosynthetic energy gathering rather than photosynthetic energy gathering that is using the light of the sun. Because in the lit realm, we have plants and chlorophyll and photosynthesis. In the deep ocean, we have chemosynthetic life with bacteria and methane-eating bacteria that actually thrive on creating chemical energy from which they are then fed upon by other creatures up the food chain that we see at these sulfide chimneys down there. Just a very incredible world, and the variety of life here has shown us that no matter how harsh the conditions, we will probably find life there. As I said on one of these SkyTour radio shows, we probably won't find life inside of an active lava lake, for instance. But guess what? We do find life forms on the walls of the lava lakes, just out of reach of the lava itself. And that's really astonishing that we could have some kind of microbial life there. But we do. And that's one of the reasons that we would choose to look elsewhere for life that's based on carbon, because there's so much of it almost everywhere we look on this planet. You'd be hard-pressed to find a place on this planet where there is no life. Even in the coldest regions of Antarctica, there's life. In the hottest regions on the Earth, and not quite inside lava lakes, inside the lava itself, you might find microbial life on the walls of the volcanic vents. It's just that's got to be the most inhospitable place to be, besides the deep ocean. But boy, oh boy, that is just an incredible revelation. I think that we are finding life everywhere we look, and there'll be a time where we'll say, well, we've discovered 10 or 15 different microbial life processes going on Mars, which I expect will happen. Well, we found a really interesting species of beings or creatures that are single-celled creatures deep in Europa's oceans. That's probably for 50 years from now. Well, I think we're going to be able to add 10 more species to our notch on the Enceladus Life Watch, Saturn's moon Enceladus. And you wonder how that could be true, but then all you have to think about is where on the Earth have we seen similar things? And in Antarctica, there's a lake a mile below the ice. It's called... Actually, it's more than a mile. I think it's a couple miles beneath the ice. I don't remember the exact depth of Lake Vostok, but it's actually more than a mile, actually. It's just over 2, I think, miles beneath the Antarctic ice. And the lake, of course, is in liquid form because it is under such pressure from the weight above. And there's over 3,500 different species of life in this lake. And the lake has never seen the light of day for millions of years. So the life forms have adapted there. In fact, they've adapted so well that they've created their own carbon cycle and their own cycles of organic waste. Nothing is from the outside is influencing these cycles. It's a totally self-contained system. And thus, this Lake Vostok is one of those reasons that we think life on Europa is not a bad idea. Might not be a showstopper, because it wasn't at Lake Vostok. Had Lake Vostok been sterile, with no life forms, well, we might have thought, it's a long shot, but maybe Europa, maybe Enceladus, right? But it turns out that, Lake Vostok has, as I said, thousands of species in it, and none of them have ever seen the light of day, ever, and they evolved there. So this is something that I think is, going to be sort of it's a bellwether of what we think we might be finding when we move off this planet. Do you have anything to add to that, Daryl?
No, I think you covered it.
All right.
I'm sorry, I was typing while you were talking.
Oh, it's okay. It's fine. That's perfectly fine.
You know more about it than I ever will.
No, I'm just, it's what I studied, but still, studies, when you go to school for something and you get a degree in something, it doesn't end there, and that's the mistake I'm always hearing when people criticize what I'm suggesting. They say, well, what you knew then was not what we know now, and so forth. And it's like, you don't know what you're talking about. It's like, well, actually, what do you think? I don't read books anymore? Do you think I don't read articles? Do you think I don't, indulge in scholarly articles, if not write some? You have to understand that, I don't just sit back and say, okay, I have a degree. No, my degree, all my knowledge, all the knowledge I have is the perfect knowledge. No. what I learned in college was how to learn, actually. When I got my astronomy degree, I learned how to learn astronomy. I didn't learn astronomy, per se. I mean, I did, of course. But I didn't learn the be-all, end-all to astronomy. I learned how to learn astronomy. I learned how to ask questions. I learned how to research things. That's the most valuable lesson out of college. See what I mean? So, I don't know. I think it's pretty interesting,
I can add one thing to it.
Please do.
It's silly and dumb, but when I was doing programs for the state parks here
Yep.
back in the 90s, it was really, really hot one summer when I was down there for the program. And, well, heck, what was the predecessor to Chomps? Chomps, I can't even say that. Just Chon, C-H-O-N?
C-H-O-N,
Wasn't, yeah,
C-H-O-N-P-S.
wasn't Chud. That was cannibalistic humanoid to the D.
Right.
You might remember that.
Urban dwellers.
Yeah, there you go, urban dweller. Anyway, it
Not
was
that
a
I've seen the bad
darn
movie.
hot. Yeah, it was a darn hot camping trip,
Yeah.
and I drove up to Montrose one day, and I bought a styrofoam cooler full of ice cream. Okay, ice
Okay.
cream bars, you name it.
Yep.
I mean, there were fudge sickles, orange sickles, dream sickles, ice cream sandwiches, you name it. Well, that was Chon, okay? And for all the hardy souls who came to the program, they all got ice cream. And I talked about Chon, so that was it.
That's great. Well, yeah, I mean, and yes, I mean the revelation of the elemental structure of DNA and so forth it takes many forms. Obviously Chon, Chomps. These are all important. And again, it's something that this is what we're made of. This is where we come from. And it's what every single life form on this planet is based upon. And I think that when you're looking at multicellular organisms, one of the things that's really interesting, and this is something Daryl, we've talked about this, the life forms on this planet are all bilaterally symmetric. They're symmetric. They're the same on the right as they are on the left. That's what that means.
Yeah.
And the reason for that, I think, goes all the way back to the way DNA replicates. DNA, if you remember, is the double helix. Okay, the double helix is not a triple helix. It's not a one and a half, or 2 3/4. It's two strands, okay, that complement each other, and they are unzipped. All right, and one strand is then replicated in some of the cellular organs, and that's how DNA is replicated in their body. All right, and that is a symmetric process. It's creating something on the right as on the left. Not the same exact thing, but it's doing this replication. And I think that earliest form of replication that started here with the life forms is why we are symmetric about our middle, about our center. And so I think that's very important. Keith's funny. He just wrote something in there. P&K Space Imaging is here, folks. Make sure you subscribe to P&K. They are the great folks over there that create the most amazing images between Paul and Keith. He threw me off, and now I don't know where I was.
You were talking about bilateral symmetry.
Yeah, I know, yeah.
DNA unzipping and all that stuff.
Yeah, well, the bilateral symmetry that we have here on this planet, I think, is going to be something that we're going to see elsewhere. Because I think the way, internally we're different, but on the outside, we interact with the environment. We have evolutionary advantage through the way we interact with our environment. And so when we mutate, then the advantage is if that mutation is favored, it will survive. If it's not favored, it will not. And that'll be the end of that lineage. So what that's telling you is that there's lots of mutations all the time. Many, many mutations. And if there weren't many mutations that occurred, then we would certainly not have been able to come to any type of evolutionary high points at all with any species. Because they would just be, they'd come along for a little while, then they would die out. but the mutations continue to this day. Evolution doesn't stop just because we've given it a name. It continues to this day. You know, it's pretty interesting. So that's why I'm really fond of this whole approach, this whole thing, because it's really something else. You know, very 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 happy to be part of a world where there's so many mutations, because evolution, remember, is mutation followed by adaptation. And if the adaptation does not work, then it's not selected for continuance. It's sort of an automatic thing, don't you think?
Sure.
Yeah.
Well, when we talked about this before, David and Marco say I'm coming in really low. I'm turned up as high as I can go on my end. Can you bump me up a hair?
I can't. I only can bump us both up.
Okay.
But
Alrighty, well, they'll just have to live with it then. Yeah, the bilateral symmetry thing, I think you mentioned starfish as an example, which do not appear to be bilaterally symmetric, but
as larvae they are.
As larvae they are. I've always wondered, I mean, there are some other life forms here on Earth that are not bilaterally symmetric. They're like radially symmetric, though.
Yeah, sure.
Plants. I wonder if I guess their DNA would still be, the same coil, the twisted helix.
Yeah, it's still that double helix. The thing is, plants are radially, like flowers are bilaterally, or rather radially symmetric in some cases. They'll have petals, and like the black-eyed Susans, for instance, they have all these petals. They all have all these things in the center that all radiate out from the center. Dozens of them. Okay, well, that's radial symmetry. And, starfish are pentamerism creatures, pentameral. They have five-sided symmetry, but as larvae, they are bilaterally symmetric, which is really odd and interesting. But that's because of the way they develop. Evolutionarily, that's the way they developed,
Yeah, I suppose octopus would... you look at them, they got 8 legs, but I would say still, if you split them down the middle of the head, that sounds gross, but you know what I mean.
Yeah.
Divide them that way, they're still bilaterally symmetric, I suppose.
Well, yeah, I mean, they're going to be symmetric as well, but with the way they interact with their environment. And the thing is that's really interesting is that since every life form is like that on the planet, we tend to think that it's very likely that other life forms we find elsewhere may very well be this way. Why? Well, because we had no part in designing the life forms on this planet. The universe provided the raw materials. And out of the raw materials, we ended up with this particular setup that we have on this planet. Now, what would be stopping us? What would be stopping any life form on this planet from developing wholly differently from anything else? Silicon-based life, for instance. Why don't we have any of that on this planet? Well... I think I know
about that. I'm sorry, we talked about that too.
Yeah, we did, and I think part of the answer lies in the fact that most of the silicon bonds they're not as complete as the carbon bonds. Carbon is the atom that can bond with the most items of any other in the periodic table. The most number of compounds is the carbon compounds that can be created. You can't find that with any other element, and not even silicon. So that is why silicon would be a much more limited life form if it was there at all. And so that's kind of the argument against life forms other than carbon. But then again, I don't want to be accused of periodic table racism.
Chauvinism?
Yeah, chauvinism and bigotry. Yes, carbon. I'm a carbon bigot. Is that what it is? But hey, that's okay. I don't mind being a carbon bigot. Why? I am carbon. So any life form is going to look for its own kind, and that's what we're trying to do. We're trying to find other life forms that are based on our chemical basis. See, I think that's pretty cool.
Life as we know it, in other words.
That is exactly right. Life as we know it. Yep.
Well, I still think, silicon makes for a good Horta rock monster from Star Trek. No kill eye and all that
Oh,
stuff.
yeah. Well, I know you want to have a Horta, No kill I. Cry for the
Yeah,
children in the hall of tomorrow.
yeah.
Yes, remember that? Great episode.
Oh, yeah, yeah. That must have really blown Spock's mind when he mind melded with the Horta.
Yeah, exactly so. Which is very funny.
I'm sorry, I'm being irreverent tonight.
You are? I didn't notice.
Oh, okay, good. Well, I'll try harder.
There you go. Well, you know what I'm going to do now?
What?
And I pointed to it before. I talked about Melot 126 or NGC 5634. It's a globular cluster, and I want to go check it out. So I think the dome might be pointing just enough so I can check it out without going out to move the dome, but I'm going to try it. So Let's go see if we can see it. And as I told Daryl the other day, we were looking at a big problem in the telescope dome. And the telescope was not working very well. Something had gone terribly wrong. So I've been spending a lot of time, and I mean a lot of time, trying to fix the telescope and get it to work right. And I discovered that I have a faulty GPS module on the telescope. So I am not going to use the GPS to do my startups anymore. And that's okay. That's not a problem. All right, let's do 10 seconds at 5,000 here.
Once you have your time and your home coordinates in, can't you pretty much operate without the GPS anyway?
Yes, you can.
I mean, you're at an observatory, so you're permanently set.
That is correct. That's very cool. Yeah. And that makes it very easy. All right, 10 seconds at 5,000. Let's see if we're in the ballpark here. I haven't looked at this globular cluster in, I don't know, I'd say 4 months maybe. Let's see. It should be coming up anytime. Wow. Well, there it is. There it is. Let's do a little instant processing on it. Yeah, that's. I'm gonna do some instant processing. Hold on. I don't want to do that processing. There's gotta be a little better than that. All right. Here's what we're gonna do. We're gonna drop this down. We're gonna raise that up. There we go. Just give it a little bit of clarity. Well, there we are. We can see what we have there. We actually have a globular cluster, but it's actually very it's small. See that?
Yeah.
Yeah. But the telescope seems to be collimated better, meaning the mirrors are aligned better. You can actually see the individual stars in this tiny little cluster. Yeah. And that's at 5,000. So let me go back and try taking this up a step and cutting it over and jumping up to, let's go and drop it or raise it up to 8,000 for 10 seconds, shall we?
I wonder if it's that it's small, intrinsically small, or that it's so far away that it looks small.
I think it's because it's so far away. The planetarium information we have on it is wrong, just so you know. It's not correct. It shows it as being like 88 light years away, and it's not true at all. Okay, so let's do this. All right, and it's this guy and this guy. There we are. Let's jump in here and see what we got.
Looks nice.
Yeah, it's pretty good for a small fry, isn't it?
Yeah.
Yeah, not bad. Not bad at all. This is the full-size frame for how big it'll be. Let me just get that. That's what it looks like. So amongst all the stars, you got this little tiny cluster out there. These globular clusters, these are amongst the oldest clusters in the entire universe. And they are on a per galaxy basis. Each galaxy seems to have a halo of these globular clusters. And some galaxies were formed later than others. But nevertheless, the globular cluster still indicates stars that are relatively devoid of other elements in their atmospheres. And that's that's fascinating. Now, I'm showing you this particular globular cluster for a reason. And that is because when in a little bit we're going to actually go see some of the other globular clusters that are out there, and we will be able to check them out, and then we're going to finally end up seeing Messier 13, all right, which is, I believe, right up here, right there, and we're going to see Messier 13. I'm not sure we can see it now with the way the dome is turned, so let me just check that out. Yeah, not sure we can. But hey, you know what? I know that we can probably see M3. So let's try it. We're going to go to M3 next and check that out. So here we go. And we're going to go in there, and you can see the stars zooming by as we zip through the sky with the greatest of ease. You can see the observatory dome down here with the motion of the telescope riding along. And in this one, it looks like we probably are going to be okay. We can see there's a couple stars here, so I think we're going to be all right. And we're going to go in and check this out now.
I see a little dim fuzzy to the lower left of that star you pointed out. I bet that's the cluster. Perhaps,
right there.
Yeah.
You can really see it. So here's what I'm going to do. Taking a chance that we're correct with that, I'm going to move us a little to the east. All right. And now you see the dim fuzzies right there in the center practically. Okay. And now let's do 10 seconds. And we go a little more east. And then jog west. All right. Now, we're going to do... I'll do 8,000 for 10 seconds. All right. So here we go. So 10 seconds, folks. We're going to do 8,000 in 10 seconds. And we're going to close in on this Messier 3, I believe, is what we're looking at. And we're going to check out how this globular cluster looks. You'll see it looks a little different, as you can see.
There you go.
Yeah. Looks a little different from the one we just looked at. It's bigger, and we're not using any greater magnification. This is just how this looks. This is how this one looks. All right. And that's a process shot. Insta processing, I call it. Get some insta processing going here. All right. And you can see now how the we can see more stars in here. And I probably could take another shot to make it a little sharper and cleaner. So I'll take one right now again. And meanwhile, we'll go back over here and wait for the other one to overwrite it, which we'll see in a second. So the other one should be coming in momentarily. There it is.
That's very nice.
Yeah, and that's a little bit cleaner looking. Oh yeah.
There you go.
So now you can actually see how these stars are. I could probably focus a little bit on these two. Probably got a little bit of a critical focus left to do on these. I might just go through a focus run with everybody shortly. But that's M3, so that's if you look where that's looking in our observatory view, you can see that the telescope is facing, is looking up here, you know. So we're actually looking pretty good.
When you swing east later in the night, once Scorpius is well up, you might show them M4 also. That's another nice one.
It is indeed. It is indeed.
Sits right next to Antares.
Yep, that's correct. So let me just drop down the music a little bit. Yeah, so that's that one. And now I'd like to actually take us to... if we're going to go up now, I don't know if we're going to be able to... I don't think we're going to be able to hit this guy. Maybe. I don't know. Should we try it? Let's try it.
Sure.
The worst case scenario, I just have to go out and move the dome. It's not winter. I'm okay with it. Yeah. And
do you think maybe some nice summer night you might actually want to go out and work out of the dome again? Or You pretty much sit in your office now.
Well, I know that you think I'm lazy, but the fact of the matter
I didn't
is,
say that. I wasn't even thinking that.
yeah, fair enough. Yeah, I think that it'll be nice to go back out in the dome, and I still have everything set up in the dome. I can actually go out there and use and work within the dome if I want to.
Cool.
Yep. But I'm doing it this way because this is the way I will be doing it in the future.
Uh-huh.
Yeah. Now check this out, folks. Okay. This is Measure 13. You can see it right there. Now, if you want to see it better, we can go into a 4K video mode. And as I increase the exposure here, you'll see it show up. And you can see more and more stars become apparent. So you see that? There you go. And that's Measure 13. And this is a live view, obviously, so it's just kind of cool. We're looking at these objects in a live manner, so you can actually see, I can move them around and so forth. It's really nice. But then, obviously, we're going to cut down and go back to, say, I don't know. This doesn't need a lot of time or a lot of exposure. We can actually go to, we probably go to 5,000 for 10 seconds. I bet you that's going to be beautiful. So let's do it.
I remember when I was still young and pretty, I think I could see M13 naked eye with a really dark sky.
Oh yeah, that's true.
Up in the high country here.
Yeah. Wow, this is pretty. That's like this is a close-up. As you can see, the stars are just a little bit elongated. There's a little bit of walking that the telescope was doing. We're gonna have to fix that. See, from when you're zoomed out, it doesn't look that bad. But the fact is, okay, when you zoom in, you can actually see that there's a little bit of movement in the stars, and the idea is to not have that. So let's get rid of that, and we'll go back here, take another shot for 10 seconds at 5,000, and then go back and wait for our overlay to come in, to have it come in, and we'll actually be able to see how much better it's going to look, if it's what I suspect. It's a little better. And there's some still. So what we're encountering is something called the periodic error in the drive. I mean, but look at this. This is stunning. Isn't it pretty?
It is.
That's just a beautiful, beautiful cluster. It is. And I'm going to just give us one more shot here. All right. And we're going to do 10 seconds for 5,000 again. And let's watch it. If I zoom in, I'll be able to see when it overlays it, how good it goes. Okay, that looks like the better of the three. And that's beautiful. That is really pretty.
I can see the propeller too.
Yes, you can. Now explain to folks what the propeller is, so they know what we're talking about here.
Yeah, well, it looks like three lobes, like a propeller there, at about 8 o'clock on M13 as we look at it, and it looks like three blades of a propeller, sort of. I can see two of them clearly, and the top one is maybe a little...
This one's a little fuzzed out, yeah.
Yeah.
But you got one right here, you got one right here. Yeah?
A little higher up. Yeah, right there. You're right in the middle of it, where you were there.
Right there.
Right there.
Yep. Very cool.
That's the biggest, best globular cluster in the northern sky, folks. There's one or two others that we can't see from here down in the south. I've talked about Omega Centauri before.
Omega Centauri, yeah.
Yeah, this is as good as it gets in the northern sky for globular clusters.
Mm-hmm. That's right. Exactly right. Yeah, and it's a beautiful cluster. I mean, this is Measure 13.
Oh, yeah.
Yep.
That's very nice.
Yeah. Yeah, indeed. I just love it.
I envy James Dugan and people like that down, southern hemisphere.
In Australia.
Yeah, they get to see Omega Centauri and 47 Tucanae and all the really cool ones down there.
Right, and they are two dwarf galaxy companions to our Milky Way, the Magellanic Clouds.
Oh yeah, of course.
But you know what? James probably would love to see some of the things that we can only see.
I bet he is. I bet he does.
Yeah. But
I don't think they can see the Whirlpool galaxy from down there. Remember correctly, that's too close to the North Pole.
Yeah. And Keith, to answer your question, Keith's asking, does Jupiter give off gamma radiation? No, it doesn't. It's not a gamma ray source, but it's you have to understand. And Keith, you know this, but for everybody else, Jupiter does have an intense magnetic field, quite a bit larger than ours. I think the magnitude is roughly like 20 times the size of ours, or 20 times the intensity of ours. It traps the solar wind particles, which are highly charged flux, from the sun. So it's trapping the solar wind, which is composed of high-energy protons and electrons. And thus, Jupiter has its own radiation belts like we do. We have a magnetic field that traps particles as well, and that's why we don't have sterilizing ultraviolet radiation making it to the ground, because many of these highly charged particles that are trying to enter our atmosphere end up getting trapped in the magnetic field and spiral around the poles. Jupiter also has the same thing happening, but just on a larger scale. And our neck of the woods here, we have the Aurora Borealis and the Aurora Australis. And that's basically northern lights, the Aurora Borealis. Well, Jupiter also has its Aurora Borealis and Aurora Australis. The auroras are not confined to our planet alone. Any planet with a magnetic field, in fact, will have some form of auroras, believe it or not. And Jupiter is no different. Jupiter also has thunderstorms high in the clouds, which of course have nothing to do with radiation, but still. And that's really interesting too, because we had never known, believe it or not, that thunderstorms could exist on other planets until we saw them in the upper clouds of Jupiter. Then we realized, wow, these things can exist elsewhere. So that's how slow science is to the draw, folks. It's not really, it seems like it's common for commonplace or a common understanding to think that maybe we would see thunderstorms wherever we looked in clouds on other planets. But until science sees them, they don't exist.
May I say, James' comment about us guys having all the good galaxies, that reminds me now what I was thinking of earlier when we were talking about the constellation Sextans, the sextant.
Yes.
I was thinking of Sculptor, the constellation of Sculptor, which does have what is it, NGC 253, great big nice pinwheel or a nice big spiral galaxy.
Yep.
I was thinking of Sculptor. I think that's over under Aquarius.
Okay.
Later in the summer sky. Sorry.
No, that's fair. That's okay.
He just what he said reminded me of that.
That's okay. That's very good. All right, now let's see here. So going back now into here, I gotta be reminded of where the telescopes are right now. Okay, our lower telescope down here is literally, it's really kind of low right now. So I don't necessarily think that that's I think we may have to change that position of the dome. I don't think we're getting the full benefit of M13 right now either.
I think you may be right.
I think we're getting it a little bit chopped off, just a little.
It looked good though.
Yeah, well, it did, because it's bright enough, yeah. But you know what I'm gonna do?
I relearned something late last night.
Oh yeah.
right up there at the upper right quadrant of the screen, that oblong horse star pattern.
Right here?
Yes. That is the head of Draco, of
Yes.
course, and you see the head of Draco always faces toward Vega and Lyra.
Yeah.
But, something made me look up ecliptic North Pole last night. I had forgotten just where it was. And there's a good Wikipedia article on the ecliptic North Pole. A really cool diagram I should have saved. The ecliptic North Pole, not our geocentric North Pole, I guess you'd call it, or whatever. The ecliptic North Pole is right there inside the head of Draco.
Yeah, right here.
And that's where the sun's North Pole is.
Mm-hmm.
Our North Pole is offset at 23.5 degrees from the ecliptic North Pole to Polaris, of course. But where the sun's North Pole and actually the North Poles of all the planets except for Pluto are right there inside that little diamond shape. There in the head of Draco.
Yep.
Yep.
That's pretty cool.
Yeah.
Yeah.
And the distance from the ecliptic North Pole to our North Pole, of course, is 23.5 degrees, because that's our axial tilt.
Mm-hmm.
As we progress around the sun, that's what causes the seasons here.
Yep.
But you could say the solar system's real North Pole is right there inside the head of Draco the Dragon.
Yeah, that's very true. That's very true. So, what I'm going to do is I'm going to go move the telescope so that we are now able to take advantage of this area of the sky, which will include the Ring Nebula and the Dumbbell Nebula, and possibly a few other items here. And
yeah.
I'm going to just put up the coordinates so you can see. These are the what we call the altazimuth coordinates. The telescope's mounted in polar manner, meaning that it's mounted such that it is pointing its axis is pointing at the right ascension axis. That is to say, the east-west axis is pointed at the North Star. Okay, this is just, if you were to put a bowl over your head, this is what we would see. Okay, with these lines indicate that. So basically, it tells us, okay, right. So for like this, if we look at this right here, this is M12. Okay, and it's just over 40 degrees above the horizon, which you can see by looking at this line right here, plus 40. So you come over here, it's just over 40 degrees above the horizon. That's what this means. So down here is 0 degrees above the horizon. Okay, this is 10 degrees in between each of these blocks. So here's 10. This is 0 down here. All right. So that's not using celestial coordinates per se. It's just using the coordinates that you would have if you were just look out with, say, just a compass and an angle measuring device. Those are called clinometers, but don't worry about that. I'm going to just go move the dome and pull us into this region of the sky.
Super.
All right.
Here comes the summer sky, people.
That's it, man. And I'll be right back, Daryl. Just entertain the many throngs.
I'll try to do that.
All right, I'll be right back, guys.
Okay. So hi, everybody. How y'all doing? Mark mentioned earlier, yeah, I got a new telescope. Oh, boy. I have been wanting a Celestron 9.25 for years on end. Ever since I first learned about them when they came out. And by golly, I finally ordered one and it got here this afternoon. I have not set it up yet. My second telescope was a Celestron 8-inch back in the days of Halley's Comet. I got it in '85. And I've wanted the 9 1/4 ever since they came out. They have a great reputation for optical design and performance, and I can't wait to break the thing out and get her going. Maybe tomorrow night, but we're supposed to have a few nights of bad weather coming. You know how it is. Hi, Papa Tom. When you get a new telescope, it angers the weather gods, and well, you get months of cloudy weather. So, thank you, David. Yeah, I'm looking forward to it. I got the basic black F10 version with, it does have the Starbright XLT coatings on it. Otherwise, it's just the standard version. It's not the fancy Edge HD or anything like that. And I also got a f6.3 focal reducer. No, James, it's not the Edge. It's the standard. I wanted to be able to use a focal reducer with it, and all the Edge telescopes are not of the standard design. In fact, each aperture size is different than the others. You can get a focal reducer for the 8-inch and I believe for the 11-inch, but you just plain cannot get a focal reducer for the 9.25-inch version. Living where I do in Colorado, we tend to get very transparent skies, but our seeing is usually terrible. The turbulence in the air, what makes the stars twinkle, because of the air coming off the mountains is so turbulent. It busts up the seeing. And so I wanted to be able to use it at a lower F ratio than F10, which is why I went ahead and got the standard black version and a focal reducer so I can operate it at f6.3 like Mark is doing with his scope here. It is a native f6.3 system. Marco, it's a 9.25-inch clear aperture version. Oh, has the 9's reducer come out? Yeah, $600. See, that's that's a good reason why I didn't get the Edge. Even if they do have it, the tube itself is much more expensive, and accessories for all the Edge scopes are much more expensive.
Yes, they are.
Yeah. Whoops, somebody's calling me. Hang on. I'll be with you. Carry on, Mark.
All right. So, I moved the scope, so I think we'll have a little more in play. We do have some high altitude clouds out there, but they are the unfortunate. Well, they are unfortunate for us, but we'll make do. We'll be okay with them. And let me see now. I want to take us over. We're going to go look at Jupiter. What do you say? Shall we?
Sure.
So let's go check out Jupiter. Jupiter is looking pretty interesting. I just want to see if we can see the Great Red Spot. It's funny. My phone just flashed because we're looking at the... oh, that's beautiful. The camera in the dome sent out a message saying, I see movement. Of course you do. I was rolling around and moved the telescope around. Huh. Okay, so let's see. Let's go and... Oh, one quick thing here. There we go. Okay. All right, so there's Jupiter, but we don't see much yet because we haven't actually decided to do anything about the brightness that we see. We shall move the brightness down here now. Let's get down from 5,000 ASA. We'll drop it down to something small because we don't need a whole lot. Drop down the timing, and you'll see now Jupiter will begin to look a little bit more real, valuable in terms of what we're trying to see. And there is, we might have an occultation here going on.
You do actually. Io is passing in front of the planet now, and Ganymede there at about 10 o'clock is just about to.
That's what it looks. So, that's what it looks like.
Yeah, there's one in front of Jupiter right now, and the second one just about to.
Yeah, I'm going to see if we can show that. All right, well, let's do this. Let's take a photo. It's going to be very quick. And now let's do this. Let's bring it up. Oops, sorry. Might need to focus that a little better. I can't see any planetary shadows, of course. That's as much as I can go. Okay, well, let's just pop it out and let's go back to this. And let's go add. Let me do this first. What's going on here? Oops. Oh, duh. Hang on. There we go. All right. Now let me. Yeah, we did see. And to those watching the dome cams, you just saw something fly by the dome cam. Yes. Okay.
Is it a flying saucer?
I couldn't tell. There we go.
Maybe it was a bat.
I don't know about that. Look at that. So this is Ganymede here, right? And we have Io is somewhere on the face of it right now.
Yeah, that little tiny little pip sticking up there at about 10 o'clock. That's Ganymede, I believe.
Yeah, okay.
Let me double check here. Yes, Ganymede.
So Io is probably right around here.
It's a little ways in from the limb to the lower right of Ganymede.
Okay.
Maybe at about 9:30, but a little ways in.
All right, let's see
And
if we can catch
I think its shadow, well, I'm looking at JavaScript Jupyter, okay? And
Yeah.
It's showing Io directly over the top of its own shadow right now, which you might kind of expect it to do, you know, when we're so close
Sure.
to opposition here.
Yeah, I'm just trying to see if we can actually pick out Io against the planet, but we're gonna have to. It's a delicate balance to try and find that. So if we were to,
I thought I saw a little dark blob there, about halfway in from 10 o'clock at the limb.
yeah, we're gonna see. I think you could be right. Okay, this is better.
You can see Ganymede distinct from the planet there now.
Yeah, there's Ganymede right there.
Yep.
And Io should be right around here.
Uh-huh.
That might be it right there. Can't really tell. Can't really tell, but it's interesting looking, I gotta tell you.
Well, that's where it is.
Yeah.
Whether we're seeing it or not. The red spot won't. The great red spot won't be around for a few hours yet.
Yeah, I don't see it again, so that's true.
Yeah.
Well, okay, so now let's go back here. I want to try something else. I'm gonna go do a little something here. See, Jupiter's pretty low right now, so that's part of the problem. But what we could do is I could bring us up to to M12. Should we go check out M12?
Sure, why not?
All right, and we'll come back to Jupiter in a few minutes.
That's an Ophiuchus, the serpent bearer.
Yep.
And that's his tail going to the left and its head going to the right.
Yep.
The snake's head, that is.
Correct. You are right. You are so smart.
Oh, I just...
For you are truly the Daryl Mason.
Oh, please. I've just done this before, is all. Oh, Amanda says she's going to be joining us in a little while, so her show's over, I guess.
Okay. Excellent. All right. Let's go up and make a nice little bit of a time exposure here. And let's bring us up to let's say 8,000 for 10 seconds. All right, and here we go. And we should see a globular cluster. And here it comes. And there it is. How pretty.
Hey.
Very beautiful. That's nice. Very nice. That's a very pretty cluster. I'm going to check star focus here. Man, it's pretty close. It's pretty good star focus there, you know? So I guess we're where we need to be. So, but that's all right. I wanted to see it anyway. I wanted to check it out and see what we might be able to look at. And we're not. I don't have us over enough to check out anything over in the realm of Lyra and Cygnus yet. And I think we're at Jupiter there, and I don't see that as a possibility there. And we can't go down too much lower, actually. But this is one of those transition places. Okay, this is M12, and let's see here.
Sorry, I was trying to post JavaScript Jupiter in the chat room, and it won't let me do it.
What, the link?
Yeah.
Oh, that's terrible.
My computer's getting weirder every day. It's acting up constantly.
Well, that's okay. You know.
Oh well.
Yeah, I just wanted to say hi to the folks that are here today. I see D. Smith is here, Harmony and James Dugan. You guys are here. That's nice to see you. Rock is here. I see Rockstar, like I said. And let's see who else. Now we have Marco has joined us. Dave Schmidt was here, and I'm glad to see that you're here. Papa Tom was here. And Flames of War was here. And unfortunately, if you guys don't, and of course Keith from P&K Space Imaging, if you don't keep posting in the chat, I wouldn't know that you're there. You don't show up in the participant list for some reason. But I'm just, I'm making sure you guys are, just keeping you honest, keeping you going in here, keeping the chat going. But I'm glad to see you guys. We had a serious problem with the telescope this past week, which I managed to work through. Seems my GPS unit has died inside the telescope. And it's good that it doesn't now before I move it 3,000 miles here away from me. So I will either replace it or I will get a whole new system. I was planning on getting a whole new system, believe it or not. But shh, don't tell anybody. Bigger telescope and more capabilities. That's what you do, when you're an astronomer, right? Just buy more tools for the trade.
Hey, tell the War Department you just went out and bought a new fishing pole or something.
Yeah, right. Very funny. Very funny. All right, let's just check out Measure 10 now. This is a globular cluster that's 14,350 light years away. But it's a really cool one too, so let's check it out. So we're going to zip to that one right now. You can see the stars are winging by here on the screen. Yeah. And then follow the telescope as it moves in the screen over there. All right, and now we will be ready. Let's see. All right, this looks nice. Okay, so let's do 10 seconds at 8,000 here. See what we get. James is funny. Yeah, I just grabbed Daryl's telescope.
I haven't even got to use it yet, Arda.
Yeah. Yeah,
I got here a few hours ago. I haven't even taken it out of the box yet.
Yeah, I know. I can't believe that. I could never let something like that sit in a box. I just couldn't. I'd have to like have it out of the box, just stare at it at least.
Oh yeah.
Yeah.
Well, I need to take it out and inspect it, for shipping damage or nothing
Yes.
else, of course. But yeah, I'll do it in the morning. 'Cause if I had got it out and got it set up tonight, I wouldn't be here right now.
That's true.
Yeah.
I wanted to
No,
just.
I'm looking forward to it. I'll be sure to give a report once I get it up. And running.
I would like to see you start doing some streaming, man.
Well, to stream, I would need video cameras. I need Wi-Fi. I need a laptop. I need a good camera. I'm not there yet. I don't know if I'll ever be that far.
No, I don't think that it's that far from. Once you have the telescope, the hard part's done. By the way, I want to say to D. Smith, thank you. D. Smith says, it's really good to see you streaming again. Yeah, that's great. I'm glad it made your night, because it made my night to see that I can actually do this. I had it all ready to go the other night. I even had Daryl on standby. You remember that, Daryl, the other night? And we were going to stream, but then clouds moved in and just totally covered us up. Why? I opened the dome. That's why. The cloud said, hey, he's opening a dome. I'll have none of that. And poof, he just came in and covered us up.
Yep,
yeah,
it happens. Like I said, the new scope, that angers the weather gods and brings down their wrath, so I'm probably looking at months of bad weather here now.
when we're ready to go with first light here with the John Zach Memorial Telescope at the observatory here, we actually we set it up. We were ready. We couldn't wait. We're just waiting for a clear sky, and we got 3 weeks of rain, followed by just like more clouds, and then finally it was like 2 months. 2 months from the time we were ready for first light to when we actually had first light in June.
I hear you. Hopefully it ain't going to be that long, but hopefully I haven't hexed myself either.
Yeah, I don't believe in that. That's okay.
We'll see.
Nah, nothing. Yeah, this is beautiful. This is a gorgeous little cluster. Boy,
that's M10?
This is M10.
Yeah, that is nice.
Yeah, it's really pretty. And now, let's see. In the globular path, let's see if we can go to M14. I think M4 might be in our view here, too. I can pull up M4, I think.
Yeah, it'll be right down below Ophiuchus.
Yeah. It sounded like you said mucus.
Oh, sorry. Ophiuchus?
Yeah. No, I'm not saying you said it wrong. I'm just saying it sounded like that from as I was in the middle of talking or saying something, and that was funny.
I'm sorry.
No, there's nothing to be sorry about. Okay. Well, folks, as you can see, I've got the telescope now aligned far better than I had it before. And that's... I went out in the observatory, and Daryl was actually with me on the phone. We were talking about why the telescope was acting up, and he gave me a few ideas, not the least of which was to go out and re-level the entire mount that the telescope sits on.
Well, that was your idea.
Well, I got it from you talking about it, and I thought about it, but...
Okay.
Look, I don't need all the credit here. I'm happy to share it.
I'm not fishing for compliments or anything.
Not at all. I know you're not, and that's why you get them.
Yeah, but I enjoy talking about telescopes with you. I would enjoy talking about telescopes with you and the people in the audience.
Sure.
I don't want to go over their heads, but maybe they can glean something from it sometimes, about the ins and outs of how they work and what they're doing, or maybe what they're not doing, as the case may be.
Yeah.
That's great.
I don't disagree. Yeah. This is another one down there. That's actually
14.
Yeah, it might be in a light cloud actually. So I'll have to.
Very nice cluster.
Yeah, it is. It is. Might be in a light cloud. That's the only other problem. All right. So now I guess if we look down here, okay, by Jupiter. Okay, right next to Antares.
Yep.
is what's called Measure 4. And I'm not sure if that's in our range right now, but we're going to try it. We're going to try it. So here we go. We're going down here to Measure 4. And I'm going to actually go into 4K mode here while we're doing this, just to see if we are going to catch dome or not. And I don't think we will. It's very low right now in the sky, though. That's the problem. That is to say, the constellation that this is in, which is Antares. I'm sorry, Scorpius the Scorpion. It's just a little bit westward of Antares. Okay, so I'm gonna pop this down, get out of 4K mode, come back up to about 8,000, and I'll do 10 seconds. So these, for those who have been here before, you know the whole layout, but I will just share it. Telescope control system over here. Me and the dome ops. Hello, right here. That's me down the lower left. Upper right, camera control. Okay, with the exposure setting here, the sensitivity, the most important two factors in the camera here. And then dome ops cams. This is dome cam 1 and dome cam 2 in the dome watching the telescope. This one here, dome cam 2, is actually riding on the telescope. And dome cam 1 is sitting on the desk within the observatory looking up at the telescope. So that's our control cluster and everything. And now what we're going to do is take a photo for 10 seconds at 8,000 on what should be Measure 4, a globular cluster next to Antares. And it looks as if it's kind of close. Might not be interfering, but we'll see. That is to say, the dome. All right, so here we come. Oh yeah, look at that. It's definitely, it's there, but look at it, how far down into the murk it is, huh?
Yeah.
Yeah, it's definitely in the murk, and it's a little bit of red, which indicates that you're looking through a cloud, or the edge of the dome is impinging on it. But hey, you gotta say, and you notice for a fact, when you look at the Measure 13. It's night and day. This is definitely night and day when you're looking at Measure 13 in Hercules, called the Great Cluster in Hercules as well. This is definitely everything in the sky is second best to Measure 13 at the moment.
Yeah.
But look how low to the horizon it is. It's pretty close. And it's there's a little bit of moisture in the air tonight. So I have the dew zapper on the telescope working overtime. But boy, it's still very pretty. I gotta say that.
Oh yeah.
Yeah. And just for
I've seen him for countless times.
Yep.
And it's kind of a roll of the dice, luck of the draw.
Sure.
I've seen it in great conditions. I've seen it in really poor conditions too, though, because it is so far south.
Yeah.
What's your latitude at, Mark? Do you remember?
Yes, 41 degrees, and 41.49.
Okay, I thought you were maybe a little farther north than that. I'm just below 39 here, so
Yeah.
our view is only a couple of degrees difference, I guess, to the southern horizon.
Yeah.
Huh.
Yep. Okay. This is the first view for the season of a star-forming region called the Omega Nebula. Let's see how it looks at 15 seconds at 8,000. And where is it? Well, I can show you where it is. It's right here. Right there. The Omega Nebula is right in here. It's right near the Sagittarius star cloud. It's right near the Eagle Nebula. We'll just try and check them out. It's sort of a pre-summer view, of the summer.
It's almost summer.
And there it is. You can barely see it, but it's there. It is very low on the horizon, but you can see the Omega Nebula is actually showing up. It's pretty good.
Uh-huh.
Now, one problem that we have is that we do have the full cutoff fixtures. That is the lights that are actually shielded so that the light doesn't go anywhere but on the ground where it's supposed to. Trouble with that is that, unfortunately, we also have these lights are now LED lights as opposed to sodium vapor lamp. And that's good, but trouble is that, unfortunately, we don't the LED vapor lamps or the LED lights are actually broadband. That is to say, they cover a lot of frequencies, so the light looks white. The sodium vapor lamps look reddish, and there's very effective filters to take out that sodium vapor lamp view or coloration. But unfortunately, for the LEDs, there isn't, because they're kind of a broadband view. So I don't know what to tell you other than we will continue to try and get the best images possible. But I am not sure that we will have much success. I'm hopeful that we will.
Progress marches on.
Yes.
God, that makes me sick to think about. I'm seeing it here too. They're putting up new lights in the downtown area.
Yes.
And they're really nice and fancy looking, sort of fake Victorian street lamps, and they're totally unshielded. And yes, they're going to LEDs now. And
that's terrible.
I belonged to the Dark Sky Association way back in the mid-90s, and I started beating the drums about light pollution here back then. And it has only gotten worse. I mean, Arizona has a night sky as a natural resource thing, and so does New Mexico, and they pushed for it here, but Colorado's so raw in development. We're turning into California East here, and it's just getting ridiculous.
I understand
I used to be able
that.
to see Milky Way from my front yard, my backyard. I can't see it at all anymore.
See, this is terrible. That's terrible. Now, I was just trying to check out whether I could see the Eagle Nebula tonight. We have a lot of moisture in the air, and the Eagle Nebula is right here, although you can't really see it too well. And that'll change, though, as it gets higher in the sky and as the moisture in the air is diminished. We'll be able to see that, later in the season.
Hi, Amanda.
Hey.
Amanda's in chat.
All right. Very, very good. Do you want to go get her?
I'm not sure I know how. Maybe you should, since you're doing the phone connection anyway.
Yeah, I was just thinking that since we had done this before, I can try and just add her to the call if she wants to come in.
I can try. Let me see.
I can add her to the call if we want. You have to do that little... I think this is all we have to do.
Okay. I wouldn't have remembered anyway, so there.
Okay. All right, well, I'm adding her, so we'll see if she comes in. I'll tell you in a minute. And she's here. Hello, Amanda.
Hi, Mark. Hi, Daryl. Hey, Al.
Hi, Amanda. Hi.
Yeah, it's very nice to see you, Amanda.
Thank you.
It is.
See you guys. Nice to see the sky.
Seeing the sky?
I said it's nice to see you, and it's nice to see the sky.
Oh, yeah. Definitely is nice.
So, did I hear you looking for the Eagle Nebula?
Yes, that's where we are. That's what this is. But the Eagle Nebula is elusive at best because of the nature of the night sky right now. It's really moisture laden, so it has a haze in it. But there's also light clouds running around throughout the sky, so that's making it hard as well. So, but that's okay. We shall just do what we can do, So I expect we'll be okay. Just have to bring it up a little bit. Try it again. We'll try to get some more. Here we are. All right, and now let's just do, we'll do 15 seconds at 10,000. Go up one stop and see what we get. All right, and we come in here now to this guy right here. This will be the viewer. These stars will be up here now when they come in. They become all moved up a little bit. So you'll see that happen pretty much now. Yeah, and we get little tails because they've all become comets. No, we have little tails because we had a little drive error right there. So I shall do it again. Yep. So how are you doing, Amanda? Yeah.
Had an interesting conversation during Foxy Pirate Radio.
Really?
Yes. I was making plans for my trip in July. I feel like you, Mark, traveling all over the place.
Mm-hmm. It's kind of contagious, isn't it? And it's actually... So tell me, where are you going to go in July?
To Toronto. I'm going to see Danny Harrison.
Wow, okay.
And ELO.
Electric Light Orchestra.
Yeah.
It's a living thing. Da-da-da-da-da. I remember that. I remember them. We can see a little bit of the eagle here. Not much because, again, it's low in the sky and it's a hazy night. But compare that to the most beautiful views of the eagle we've had, and it's just beautiful, when you look at it sometimes. But boy, oh boy.
Mark, is that a yellow star up in the upper right quadrant?
You're talking
about zone 3.
This one?
Whoops. Pardon me. I'm sorry. I was looking at the wrong screen.
You're probably talking about on this one.
I think.
Sorry,
I'm back on your screen now. I was looking at the chat screen.
Okay.
There was a very yellow.
This one.
There you go. There it is right there.
Yeah. Yeah, this that's an interesting star. I'm going to actually go look at that again. Let's go down. Okay, we brought this up. It's off the view here. Let's go bring this down again and check that out again, because I think that's actually a really fascinating star. Let's go look. So we're going to go and bring this down. So we're moving the telescope somewhat north. Okay, so right about here is where it was in there. We're going to just bring a little bit more. All right. And I think this will acquire it. And I expect it's going to be right about here. So let's look right about here and see. So we're going to go over here now. There we go. And we should see it. There it is.
I see it.
Right there.
Huh. So that's real?
Yeah, it's real.
Wow.
Yeah.
Such a striking color difference to everything else.
Yes, it is actually, isn't it? And yeah, I'm gonna actually do to try and showcase the color a little better. I'm not gonna defocus like I'd love to, but I actually spent time to get the focus really good, so I don't want to do that. But what I am gonna do is I'm going to cut down the exposure time a little bit. Let's go down to say 6 seconds. And we'll take another picture in 6 seconds here. Same thing. And the sky will be darker, and this star should be a little bit dimmer, but a little bit more cohesive. Let's see what we get. There you go. See the difference now?
Yeah.
Look how stunning that is. Isn't it great? All right. So, if we want to know what that is, why don't we go on a little mission? And here's how that mission works. We go over to our little planetarium and we jump into here. All right. And just below the eagle up there is this star right here. Okay, and that is it's an actually unnamed star, but it's definitely a reddish star, as you can see.
What if you
see that? And it's actually, it even has a
yeah.
See, it has the second one next to it that we saw.
Uh-huh.
Yeah.
Interesting.
Yeah.
And they show the yellow color also.
Yeah. That's right. And for those wondering why the screen
So
seems
would
to
that be maybe like a G star?
probably like a K at a very minimum, most likely an M star, but it's 11th magnitude, so it's pretty bright. You know, for an M star, it might be a K star. You know, which I think is really interesting. The other interesting thing is I'm trying to select this star and it always selects the other one. That's kind of weird.
Huh.
Well, even out here, it selects that one. That is pretty crazy. Well, anyway, that's cool. So anyway, yes. So those are those two stars we looked at, and we can get their information here. We don't actually have anything of real true value, but it has a. Let me explain this here. It has a color index of B minus V of 2.96. That means it's definitely a very reddish star, which you can see visually, of course. But this color index you see in the upper left, that tells us a lot about a star. We look at color indices. And usually a star like this, if we see a color index that's above 2, then it typically is going to be probably an M star. Whether it's a giant, supergiant, like a red giant, or a very small dwarf star, like our sun's a dwarf. And the M star is just one half of the classification. The other half of the classification is the luminosity class. So like an M2 star can be a Roman numeral 5 star, like the 5, M25, which is a dwarf, which is like a regular hydrogen to helium fusing star. Or it can be a 1A, and this Roman numeral, 1A. So that means, like an IA. And those are supergiants. And you can have those as well. Remember, the color is really related to its temperature and not related to its size per se. Because you can have a small red star, you can have a massive red star. It just depends on what's going on in the star and where its state of evolution is.
May I throw something in there?
I certainly hope you will.
Okay, up at the top left where the legend and all the information is, magnitude 10.85, but then it says in parentheses extincted to magnitude 11.16. Talking about extinction, is that like dust in the way that's reddening it or something?
Well, the extinction coefficient here, I believe this is stellarium. I think they're basically saying because of its elevation above the horizon, it's extincted by our atmosphere.
I get
it. So it's been dimmed by our atmosphere, and that's also a little more reddened as well. This B minus V index should be the one without the atmospheric reddening. What do I mean by that? Well, you see it every day of your lives. Every time the sun sets, the sun is what color? It's orange when it sets. Well, it's orange because the light is passing through our atmosphere. The atmospheric molecules are very, very efficient at scattering blue light. They actually scatter all light. Okay, they take in a lot of the light and then they scatter it in all directions. But blue is scattered far more than the other wavelengths. So you get predominantly the red, orange, yellow, being let through. And so that's why sunsets look red. So the same thing here with stars. These stars are not red in the sky because of the fact they're not red here because of the fact that these stars are traveling through more more air. Okay, because these would otherwise be red as well. No, these are this orangey red because that's their spectral type overall, and that means its number, its letter designation, as Amanda loves to talk about, is they go from OBAF to GK and M. These stars are probably in the K realm, and maybe possibly in the M realm, and then their luminosity class determines how bright they actually will be in the sky. So this could be an M supergiant very far away, or it can be a M star much, much closer to us, an M dwarf like the sun, much closer to us. So we'd have to do the studies to figure out how far away they are, and they would have given the distance of the star if they knew it. But these are actual stars right above there, and boy, they're just something else, aren't they? Look at that color.
Yeah.
I'm wondering if it might even be a carbon star. That's another.
That's what I was wondering.
Yeah, carbon stars are stars that have a predominantly large amount of carbon on their surface as part of their chemistry. And it has to do with their evolutionary state and how they evolve. There's a lot of carbon stars.
Carbon star?
What's that?
Is our sun a carbon star?
No. Our sun is not a carbon star. The carbon stars are generally M-type stars, M-class stars, like, the coolest stars. And some of these stars are so cool, like these M's. They're so low in temperature that they can actually have molecules in their atmosphere, which is really fascinating because, molecules can't exist under high temperatures. But the stars are so, the star temperatures are so cool that it can actually have a molecule form in its atmosphere, which is really fascinating. Just incredibly cool.
And are the cooler stars the ones near their life cycles?
Near the end of their lives?
Yeah.
Well, not necessarily. Actually,
not near the end of their lives, but closer to the end of their lives.
No, not really. And you know why? And that's actually not an uncommon thought that you're having, and that is that M stars just fuse hydrogen to helium very calmly in the background, and because they are so less bright than our sun, they can exist for trillions of years as opposed to our sun, which can go only a few billion or 10 billion. And so a few trillion years of life for these stars gives them ample opportunity to potentially evolve some strange forms of life on its surface, on the planet surrounding it. So I think that's kind of a cool aspect of all this, So stars like this that are M stars, they don't necessarily, they're definitely not, short-lived. They're not short-lived like an O star. You and I, Amanda, we've talked about O stars, as you and I have talked about it, Daryl. And O stars are the hottest and bluest, and they only live between 10 and 150 million years before they go supernova almost every time. And like the stars of Orion, we're so used to seeing the three belt stars of Orion. Well, when Lucy, Australopithecus afarensis, was in Africa, the belt of Orion didn't exist as we see it today. There were only two stars in the belt back then, and one of them wasn't even formed yet. But it's only going to be a few more million years before that star, another O star, obliterates itself in a supernova, and the Orion's belt's going to go back to looking the way it did when Lucy was around. So, yeah, it's pretty cool to think about how our history is just a blink in the eye to the universe.
I find this fascinating. This star, I mean, it's just so, it's
Striking.
unlike anything else in the field. That's such an intense yellow color, or orange. And what I thought was it and the little one next to it were both the same color, but if you zoom in, you can actually see, I think the color from the big one is sort of overwhelming the little one. The little one does look paler.
It does.
It's not as bright orange as the other one.
Yeah, this might be, we'll have to look this up. This might be a...
Is that because of the size, though?
No, it doesn't necessarily have to be because of the size, but just the fact that it might be just a brighter star intrinsically. And the camera is exposing for, X amount of seconds, and in that amount of time, this particular star's brightness can come through a lot brighter, even though, it might just be that the star itself is intrinsically brighter. And you won't really see that until you actually do this kind of thing, take a photo of this nature, you know. But that is just a beautiful star. I'm glad you caught that, Daryl.
Oh, hey, it's pretty.
Yeah, can't miss it.
It's so different than anything else in the field. I mean, it
I
really
know.
jumps out at you.
It does.
Cool. Thank you for showing us that.
Of course. Yeah, and the nice thing about this planetarium program is that we can actually go see what those stars look like and which ones they are exactly, and I really like that.
Uh-huh.
Yep. All right, let's see
really
now.
Something.
Yeah, it is. It is. And I want to go and see if we can now look at. Let's see if we can do this. I mean, nothing down here looks good tonight, so we're stuck. As much as it's tempting to go down there, there's really nothing down there that we'll be able to see. However, I do want to look for. Oh, these guys might be candidates too. I think this is one right here. Here we go again with this. Why? This is the only bug in this whole system here is I want that star to get selected. And when I click it, it does the one next to it. Ay. It's almost like it doesn't want to do this, you know? Crazy stuff. Yeah. But these are stars that are, magnitude 9 and greater. We don't have any data on them besides that here in this planetarium. But we could find more. We could go in the Sinbad and SEDS, which are other databases. It's kind of cool to check out the other databases, guys. If you just go out and look online, there's some really, really neat databases out there. And I think that would be something to check out. Then Sinbad is one of them. SIMBAD, Sinbad. And then another one is SEDS, SEDS. Another one to check out. And these are ones that astronomers use, to check out the nature of the stars and so forth. And there's a lot in there that, might be a little confusing. But you know what? I'm always here to ask if you want to ask questions about it. So if any of you are familiar with Sinbad and SEDS and you want to know what's going on, I'd be happy to help you. I want to do one thing. Oh, you know what, Amanda? I want to look, but it won't work right now. There's something that is up here, right here, that you like. Do you see it?
I saw it on the screen before I could say it. I was wondering if that's where you were gonna go, but what? We can't go. Why? Clouds?
Clouds for one thing, and for another, I think I'll have to go out and move the dome for sure to be able to see that. Because we're looking at the other side of the North Pole area. Okay. So see, here's Polaris.
Yeah,
here's the North Star.
Polaris. Furcad down below Kochab.
Mm-hmm. This is the North Star right there.
Yeah, there's Cepheus already.
Mm-hmm. Yeah. Yep. And so
Remember, Amanda, Cepheus is Cassiopeia's husband. The Queen of Ethiopia, Cassiopeia, in the fall sky. That's her husband, the king, coming up right there.
Yep.
I thought Cetus was the whale.
Oh, yeah, Cetus. I'm sorry.
Cetus.
I would say Cepheus or Cepheus.
Oh, Cepheus. Okay.
Right, there you go.
Yeah.
Yep. And this will help.
Sorry. I'm a mushmouth tonight.
Nah, it's okay.
Yep. And that's in Draco.
Yeah, see.
The dragon.
Yeah, right there. Yeah, so we can't look at it tonight, unfortunately. but I would like to, at some point, do that for you again.
Thank you.
Of course.
It's gorgeous. I think
Yes, it is.
would
It's
enjoy
just
that.
beautiful. Really is.
Folks, will you excuse me just a moment, please?
Sure.
Yeah, no problem, Daryl.
Thanks. Be right back.
Okay, we'll be right here. Okay, I have the telescope aiming kind of in this direction right here, so we're sort of in this direction. Let's go back and look at Jupiter again. We looked at Jupiter,
Ooh, good.
and we saw Ganymede heading behind Jupiter, and Io was in front of it. And we didn't really see Io that clearly, but it was there. You could tell, right? And there it is.
Wow.
Yeah. Yeah, and right, so now let's zoom in on this and see what we get. What do we have here?
What is it? Don't tell me. Is it Io, Europa, Ganymede, Callisto?
Yes, but
In order, yeah?
yeah, but that's not how we see it here in the screen tonight.
No.
Yeah, because of course we don't have.
Is that Io on the left?
I'd have to look actually, which I could do really quickly with everybody. I can just do that. We can get all this information right instantly. Let's do that. Let's find out where we are. So we're going to go right into our planetarium program and zoom in. We're going to zoom in on Jupiter. And we have Callisto out there. Ganymede has already just gone behind. Okay, you can see Ganymede just going behind. Io is in front. Okay. I should say Ganymede in front, I think.
I believe it is, yeah.
Yeah, and Io is...
Hi, I'm back.
Hi, Daryl. Io's in front now, about midway across. There's no great red spot at the moment. And then farther out, we have Europa.
So Callisto on the left looked so close. But that's technically the furthest out.
Well, in the view we had, yes. That's right. So if we go like here...
Yeah.
There's,
That's because Callisto is either coming around from behind Jupiter or getting ready to pass in front of it also.
yeah, and there's Callisto. I'm going to drop down the exposure. Actually, I'm going to drop down the ISO here. And then we'll be able to actually see a little better what I'm talking about. All right, let's not do 6 seconds. Let's drop this down. Let's try this to see if Ganymede is just visible as a little nub sticking off of Jupiter at this point.
Will we see Io as a black dot in front?
Not necessarily. Not in this view right now, but we're going to try. Okay, I don't see Ganymede anymore. Here's Callisto. Here's Europa. I'm also looking at it. Look, these images are a little bit screwed up, and I might have a dome in the way here. Might have a dome in the way a little bit. So let's go back to...
If Ganymede is behind Jupiter...
Yes?
And Jupiter's just a gas giant, why can't we see right through it? Gas is too dense?
Yes, because there's too many impurities in the atmosphere of Jupiter to see through it. It's like Titan. Titan's, Saturn's moon, Titan. And we can't see the surface of Titan without using radar. And the reason is because of the fact that Titan has an extremely hazy, dense atmosphere. And that's a problem. That is a problem.
Ganymede is passing in front of Jupiter.
Yes. Yeah, I thought we said that. It was, yeah.
Oh.
That's okay. So, all right. So, I do have a little bit of a dome issue. That's why it looks the way it does. It's got this little strange shadow or brightening here. That's a good song, too. This is a great song for this, The Blue Danube.
I don't hear your music at all now.
Huh.
Me neither, but Daryl sounded low compared to you on YouTube when I first joined.
Okay.
Skype he sounds nice and clear, but
Yeah.
I don't know.
Well, I'm going to start sharing a screen again here for you guys so you can see it again.
Amanda, those cookies are so unbelievably good, you wouldn't believe it.
Wow.
You need to try that. And they're easy to do, too. The whole thing took about 10 minutes.
Wow.
And he's eating them now, you can tell.
Yes.
Me? Not me. Here, let me mute myself. Cookies? What cookies?
Yeah. I want to say hi to Harry. He's here. Hey, Harry Michigan. How you doing? Harmony, hello. Justin T, nice to see you. I said hello to everybody else so far. I am going to move the dome one more time, and we're going to go see if we can look at M57. That was the target list for tonight. We mentioned it earlier. And right now we have this is the Jupiter with the moon. Callisto, Ganymede is just at the edge here, going in front of Jupiter, and is in front of Jupiter. Io is right there around the center of Jupiter, which you cannot see. And then we have Europa over here. As far as getting this to look a little better, I'm going to reduce this a little more. And let's see what we can see here. All right.
I hear the blue Danube now.
Yeah, that's right.
Me too.
Okay, so here we go. Oh, yeah, you can see where Ganymede is right there. In the upper left corner. Yep, it's right there. Yep. Yeah, no doubt, you can definitely see it there. Right there. Io is about here. Yep. Very cool. All right, well, Amanda, you and Daryl can keep the troops entertained, and I shall just run out and get a little get the telescope moved a little bit. How's that sound? Or get the dome moved. Okay, so we can look at the other summer stuff. I'll be right back.
I'm going to talk about my cookies while Mark's done. Oh my God.
It seems to be a theme to make people hungry in chat. It happens every stream.
Oh, well, golly, folks, I made some no-bake chocolate peanut butter oatmeal cookies tonight, and they are so freaking good.
You didn't tell me about the peanut butter.
Yeah, I've made them before with a different recipe. A lot of people, hopefully you know what no-bake chocolate oatmeal cookies are. I made them before. There's tons of recipes out there. The last one I tried, I think they put coconut in it with the oatmeal. They were okay. But these things, though, they're you whip up sort of a chocolate goo sauce, whatever, in the saucepan, and you put peanut butter in it. And the peanut butter really kicks these things off. Good grief, they're good.
Shep wants the recipe.
Oh gosh. My copy and paste isn't working tonight, Shep, or I would do it. I was trying to paste something in earlier in chat and it wouldn't let me do it. Oh goodness. I wish I could help you. Let me see if I can find the link. I shouldn't talk about it if I can't back it up, huh? I sent you the recipe earlier, Amanda. Give it a try, seriously. I mean, if you came to trust me with the guacamole, I bet you would love these. These things really rock.
Oh, Bill said he made some last night. He made more guacamole last night.
Oh, did he?
He did, yeah.
Okay, I missed that. Where'd he say it?
Oh, he told me earlier today.
Oh, okay.
I was chatting with him, and he said he made more guacamole, and I said, now that I'm not there, and you actually got to try some, what did you think of it? He loved it.
Good. I'm glad.
I ate the majority last time. If anyone saw Bill's video after we made it, yeah, I ate a good majority of it.
Good for you. You were hungry. You hadn't eaten all day.
I was hungry, but still doesn't justify my gluttonous behavior.
Yes,
And
and
especially on
you're
film.
so heavy, Amanda. You should really lose some weight, you know?
No, I pigged out on that guacamole. I'm not even kidding.
And what did you get your weight up to? 100?
Huh.
Well,
Gentlemen shouldn't ask such questions.
but this is
that
Amanda,
warmed my
and we've
heart, though.
talked
I know
about
you
it.
had great moments on your videos, like, you know, the Imagination Circle and or Imagine Circle and
Yep.
Strawberry Fields and all that. But me seeing you go to town on that guacamole just warmed my heart.
Well, that was your recipe, wasn't it?
Yeah.
Mm-hmm. Yep. I did want to say, you know, it was really nice to finally meet Amanda in person after she's been my co-host on SkyTour Radio for over a year and SkyTour LiveStream for well over a year and a half. And I had never met her. So when she came to Pine Bush, that was really cool.
Dude, we must have just missed our anniversary. It's got to be 2 years for live stream now.
Yeah, well, I mean, unfortunately, the
Because
weather
it
was not
just in
conducive.
June.
Yeah,
You what?
the weather wasn't conducive to celebrate it, you know?
Hi,
Okay.
Keith.
Oh, Keith's back. All right. Yes, Keith. This is a black hole. No, we're actually in between objects. I'm actually going to take us over now to. We're looking at the dome right now, but we're going to go over to. We just looked at Jupiter, and Ganymede was behind Jupiter. I'm sorry, in front of Jupiter, and Io are both in front of it, and you can see the projection of the shadows. And we could see where Ganymede was with its shadow. Its shadow was the most
That's a
prominent.
cool picture.
Yeah, this is the planetarium view.
With the moon and the shadow on it.
Yeah, yeah,
I like how they did that.
yeah. And now let's pull out of this and go. All right, because I have the view over here. We're gonna go look at.
1057.
Yes. Harry asked for that, and I take requests, so we're gonna do that. He's the only request I saw. There might have been more. Okay, so let's go
I was
see.
getting to it, but we had just gotten to Jupiter, so I wanted to stay
Okay.
there for a little bit.
That's fair enough.
Let's get into it. There's some people munching and back and forth. I thought Keith was streaming earlier. I could have been wrong. I know Bill was streaming, probably still is.
Yeah.
I was over at Earth Radio, and people are in and out, but I'm keeping my eye out for requests.
Okay.
So keep coming, folks.
Yes, now that Amanda's here, we can catch those a little better.
No, Daryl does a good job of keeping his eye on chat, too.
Oh, well, that was the part he wasn't saying. Amanda does a better job than Daryl does at catching requests.
Aww.
Well, that's kind of true that Amanda is really tuned to it for some reason, and neither Daryl or I are as tuned to it. But then again, I'm tied up doing a bunch of things, and Daryl's always looking furtively at the screen, wondering what we're doing, and so I can't, can't blame him.
Or eating cookies.
Or eating cookies, or talking about guacamole. No, I'm just kidding. All right, 8 seconds at 6,400 here, and let's go see if we can grab the Ring Nebula. Should be right about here, if I recall. Or maybe a little lower. Yeah, it's going to be lower. Okay. Fair enough. All right, good. Well, let me... Oh, sorry. It wasn't... Yeah, there's the Ring Nebula. Okay, here's what we're going to do. We're going to go back to this view here. Our wonderful view. And we're going to bring the Ring Nebula up into the view some more. And over into the view some more. And if you want to know exactly where it is, we just go to 4K mode for video for a moment. And it will pop into view right around now. You should be able to see it. There it is, right there. So while we have this up, we can center it up and do it in real time. See, we're doing this in real time, folks. This is cool. Faint objects seen real time, and this is kind of, it's sort of unheard of, and I don't know anyone that's really doing it just this way, actually. Which is why SkyTour LiveStream has become somewhat popular. I'm so humbled. It's wonderful, and with people like Daryl and Amanda helping me out, I mean, these guys are, they have their own contributions they give. And Amanda, she says, "Oh, well, I don't know much about astronomy," and then she turns around and shows you just how much she does know. I'm telling you, folks, Amanda has learned an awful lot, and Daryl knows an awful lot, so it's a perfect team here.
I'm the guy riding shotgun on top of the stagecoach. I'm the guy who makes the silly comments. That's beautiful.
Yeah, isn't that pretty?
The Ring Nebula?
Yes, it is.
It is.
There you
What's
go,
that
Harry.
color from, Amanda?
Ooh, yeah. Can she answer?
03?
Yay. 03.
Wow.
03, yeah.
Doubly ionized oxygen.
That's right.
Ah.
And the 03, it's called 03 because 01 is the base state of oxygen. 02 is singly ionized oxygen. Okay, 03 is doubly ionized oxygen. And we do this just to confuse everybody. No, actually, it has to do with the transitions, the atomic transitions of the electrons. What's ionization? Ionization is when an electron has popped off the atom, however briefly. When it recombines with the atom, based on where it goes down to in the atomic levels, there's a bunch of discrete levels in an atom for energy. They're not just all anywhere. The electrons can't go just anywhere. They have to go to these discrete energy levels, and those discrete energy levels are labeled like n equals 2, 3, 4, 5, etc. And if an electron jumps down to a certain level, it gives off a certain color of light because there's a certain amount of energy given off at a certain wavelength, that is color. And so hydrogen going down to level 2, n equals 2, in the hydrogen atom gives off a certain color of light, and that happens to be the light of hydrogen alpha, the red light at a certain specific wavelength or color in that transition. And so 03 is what we see when we have these doubly ionized oxygen, and the recombination color of those electrons are several, but the predominant one is this bluish color that we see, and that represents a specific atomic transition. It's a transition we can't see anywhere in the Earth's atmosphere or anywhere here on Earth, so we call it a forbidden line. Obviously, it's not forbidden. And M57 is what we call a planetary nebula, and you can see this little tiny dot right in the middle of it, right here. And let me see if I can zoom us in a little. Okay, this little dot right here is a white dwarf star. It's the remnant, the dead star remnant from what was once a star. This stuff on the outside is this doubly ionized oxygen with hydrogen as well. Okay, you notice a little reddish glow too. You're getting a little bit of the reddish glow from hydrogen alpha there, which is the red glow we're talking about from hydrogen. And then so that the end state of the star is that it's blown off its outer layers and then shrunk down to a little white dwarf that you see there. And this isn't the best way to show this, so I'm going to show it a little better here. Let me go and I'm going to get down from 8,000 4 stops and go up a couple. 1, 2. Yeah, we'll go to here. And now we'll do 15 seconds at 2,500. And now you'll actually see it'll be a little bit more clear if we don't get the telescope to wander a little bit from the wind. There's a little bit of wind out there. So I'm taking a chance going 15 seconds. Let's see what we get. Okay, that's not so bad, huh? All right. The only thing is, at 15 seconds, we don't catch the central star. The central star of the Ring Nebula is very faint, and we would have to go a little bit longer to catch that. But this shows the colors on the outside. It shows the oxygen 3 out here. And you'll notice the center part of the nebula is hazy and not black like this area around it. There's a reason for that. The reason has to do with the fact that this stuff isn't just in a ring. It's actually an enveloping material around it. It could be barrel-shaped, where we're looking down the barrel of this nebula, or it could be ring-shaped, or spherically shaped, rather. So that where it's thinnest, we'd be looking like here through the least amount of stuff, and it would be shallower, and on the edges it'd be thicker. But the recent historical analysis of the Ring Nebula shows that it might be this long barrel object, and we're looking right down the barrel by chance. I find that to be a little bit too coincidental. I think it's more of a sphere, and on the edges of the sphere, we're actually looking into more of a we're looking through more material, and then over the front and back we're looking through less, so it tends to look like this. That's my feeling, but I could be wrong. I could be wrong. Anyway, that's kind of what the thought process is for me on that.
Harry wanted to know what the origins of M57 were.
Yeah, I saw that. I actually answered that. That was actually it was a star. I didn't fully answer it though, so thank you. That's true. It used to be a regular star like the sun, and then as it ran out of hydrogen, it swelled into a red giant. And as these red giants do, sometimes they pulsate. They get bigger and smaller. In the process, they might puff off these outer layers, because the star can get so big that the material on the far outside edge of the star could very well be material that's almost not gravitationally bound to the star anymore. And so the slightest outward pressure, from radiation of the inner core of the star, this remnant, the slightest outward pressure could cause it to leave the star's environment and go out into space and start traveling outward. And they don't move out very fast. They're moving at like supersonic speeds, not at fractions of light speed or anything. They're moving at supersonic speeds, and the material goes out slowly but pretty far. And it's a sort of rule of thumb that many of these planetary nebulae are about a light year across, which is kind of interesting.
He wants to know what the distance of the Ring Nebula is. I don't know if he means from us or the distance across.
I think he means...
I'm not sure. I guess it depends on if it's a barrel or a ring, right?
Yeah, but the bottom line is that the Ring Nebula is actually pretty far away. It's like 2,800 light years away. And when we look at it, okay, you can see, and you look at the Ring Nebula up close, okay, you can see, and this is in our planetarium program. Let's go in here and get in here. You can see what I was talking about. There's that, they have this central star, and you have this bluish O3, then you have this reddish part. The bottom line is that you might not see a lot of the red in my shots here, but the fact is that some of these colors are not exactly as they really are in real life. Sometimes they're exaggerated a little bit, and that's kind of what we might be seeing here. I'm gonna just yeah, go ahead, Daryl.
I'm sorry. Isn't some of the red in the Ring Nebula from neon out around the edges, or is it all hydrogen?
No, it could be. There's more than oxygen and hydrogen in the nebula. There's quite a lot, in fact, of other elements. In fact, all the elements made in the star and the outer envelope, and all the elements that it was made with, could be causing this glow to occur. So yeah, there's other elements for sure. You're not wrong about that.
I could be totally wrong about that. I thought I'd read or heard somewhere that some of the red fringe you see some places around the ring might be from neon.
Yeah, I don't
remember for sure though.
Yeah, no, I don't.
And neon has that nice, red glow to it.
Yeah.
Like a neon sign.
Yeah, that's right. Yeah.
I forget.
No, it's okay. I mean, first of all, it has helium, it has oxygen, of course, it has nitrogen, it has neon, it has sulfur. So it has a bit, it has quite a lot of, it has quite a bit of a chemical soup going on up there. And that's okay. I mean, that's exactly what we expect, in a planetary nebula. And now, if you think about it, we also have, I think we have fluorine atoms in there. We have hydrogen, we have helium, we have oxygen, and we have nitrogen and neon and sulfur, argon.
Put that to a song.
That's right. We have nitrogen and there's neon and sulfur. Yeah, and you have argon and chlorine. You have a whole bunch of chemistry going on in that nebula, Daryl, which is again, it's all the materials that were in the star's atmosphere to begin with. Some of which it could never make, some of which it did make. And the helium for sure is one of the ones it did make. But anyway, so you are not incorrect in saying that the Ring Nebula has that. Most of the nebula have a panoply of atoms in their envelope. Most of these planetaries have that.
I'm sorry. I didn't mean to make you digress. I just
No, it's not a digression. It's actually good.
The red and neon came to mind.
Yeah, no, that's fine. And again, it's going to be a mix of many different elements that we see in these nebulae.
Sure.
All right, so now that we've done this one, I would like to go to...
Ian says, what's your 20 dome ups?
What's your 20 dome ups? Oh. Okay, my 20 is Terryville, Connecticut.
That's what I was thinking.
Yeah.
What's your location?
Yeah, I think that's what he means. That's correct. All right, now let's go down and let's go check out this one. This is the Dumbbell. This is another planetary nebula that we're very familiar with. And let's see if we can see that without any disturbance from the force and or the dome getting in the way. Oh, this looks bad. Not bad, but good. Okay. Okay, our telescopes look like they're looking out, or the telescope looks like it's looking out the slot like fine. That's a good thing. The telescope has stopped moving. All right. Shall we do 15 seconds to 3200? Yes, we shall. So here we go, and let's go check it out. And we'll go back to our view here. That's that, and that's the process view, which I don't like because I didn't. All right, now we're going to go to measure 27. Oh, there it is, way down there. Holy cow. It's definitely... It looks almost black and white, and the reason is because it's in the mush down there.
Mush?
Yeah, a lot of the murk, and there's some clouds down there. So whenever you have a little cloudy area, it just strips the color away pretty quickly. And Daryl, right here in the middle, there's another one of those red stars you like. Yeah. That's how you know you're near the dumbbell. When you can see that red star. All right, let's go see if we can. Oh, there! Look at that! 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 Did you catch that satellite?
Zoom.
You catch that satellite?
I did.
Yeah, it'll be in the replay. That was cool. And that was in the live view, too, which is kind of neat.
You know, that reminds
on YouTube.
reminds me, I saw an image a few nights ago.
Yeah.
Professional Observatory was shooting, I forget what, it was a supernova in another galaxy.
Yeah.
And while they shot the exposure, 25 of those Starlink satellites went through the image. And they're not all running in a line anymore. They're spreading out, away from the original orbit. And so you didn't have one streak across the image. You had 25 streaks ruining the image.
Yeah.
It was really something.
Yeah, which is...
I should have sent you that. I think it was on Space Weather.
Okay. I will check it out. Okay, so now let's do this again here. That last shot we just did was better than the first.
It had color.
It had color, yes.
There you go.
Yeah, and this one did not, but this one did. You can tell the difference.
Interesting.
And now let's see. Okay, the next one here we got a little. I didn't do the backlash motion, so we have a little backlash in there, but that's okay. Backlash is when you set the scope to one location and the drive gear has a little bit of looseness in it and basically can travel a little bit before it actually comes to a halt and starts guiding again.
In my career as an industrial mechanic, I had to deal with setting backlash on like spiral gear sometimes.
Yeah.
Sort of like if you ever messed with automobiles in the old days, when you're setting the differential gears in the rear end of your car.
Yeah.
That is about a black art if I've ever seen one to setting that backlash correctly. I mean, you're talking bare thousandths of an inch there, and it's just I got pretty good at it. I don't know if I was lucky or good, but that's a royal pain sometimes.
Oh, I believe it. Well, here we go. This is a little better view now.
You can see the apple core shape.
Yeah, you can see the apple core shape right there, this is the core right here you look at. And you can see the tiny little star in the middle, that white dwarf star, which we've talked about in SkyTour Radio on kgraradio.com. We've talked about this rather extensively. It could be that the central stars in these planetary nebulae could actually be Wolf-Rayet stars. And Daryl, you've talked about this before too. You're familiar with that whole process. Yeah. Wolf-Rayet stars are very powerful stars, very luminous, and kind of stars leading up to supernova status. But we know that in the Dumbbell and in the Ring Nebula, for instance, these are definitely the result of stars that have shed their outer envelopes. Okay, so the likelihood that they're actually Wolf-Rayet stars is lower. It's in things like when we look at Thor's helmet, where you don't see a real structure to the nebula. It does have the same colors, but we don't see the same structure. In this structure here, you'll notice that you see a lot of material heading out this way, you see a lot of material heading out the bottom, and less on the sides. In fact, this narrowed waist in the middle shows that it seems to have some kind of polar look to it, where it's going out of a north and south pole, or an eastern, a hemispherical thing. This actually could be, this is actually called a bipolar nebula, and it's not because it can fly off the handle in 1 second and be happy as a clam the other. It's not that kind of bipolar behavior. It's bipolar because of its shape, and the Ring Nebula may also be bipolar, and that's why they talked about the prospect that we're looking down a barrel in the Ring Nebula. But anyway, this is just a sort of a preview of the summer to come, folks. And with that, I'm probably going to, I am going to have to close for the night because last time I was out there, I noticed there's a huge bank of clouds heading our way. So we're pretty much done for the night. And I'll have to go out and get the scope all buttoned up and protected pretty quick. But I did want to just make sure you guys saw a few of the summer highlights before the summer arrived. I guess I'm kind of giving you some summer spoilers. Yeah.
Or previews.
Yeah, exactly. Yeah.
Yeah. Well, thanks for having me, Mark. And Amanda, it was super seeing you. Thank you for joining.
Sorry it was so late.
It's okay. You had a show to do.
It was hard to even wake up for the show I had to do. So.
Oh no.
But I'm glad I got to drop by for a bit, and thank you to everyone in chat for hanging out with us and coming up with some great questions and some great requests. And
yeah, I'm very pleased. It's nice to be able to
do it again soon.
Nice to be able to see you guys out here again for a while. Yeah. Okay, Ian, good to see you. Thanks for dropping in. And yep, Shep, thank you very much for dropping by. Harry, thank you so much. D. Smith, thank you. And especially Daryl and Amanda, thank you both for making this a very special evening for everybody. Thank you, Harmony. We'll see you guys on the next SkyTour livestream. And I will talk to you guys very soon, I'm sure. If you have any requests or if you have anything you'd like to say to us, you can also find us over on SkyTour Radio. And the email for us over there is SkyTourRadio at KGRAradio.com. Yep, SkyTour Radio at KGRAradio.com. And we'd like to hear from you if you got any questions or things you'd like to talk about. And we do have a call-in line now on SkyTour Radio. It's sponsored by the Paranormal app, and we will be happy to listen to your call and talk to you there as well. That's Sunday nights, 8 p.m. to 10 p.m. Eastern Time. An extra hour by popular demand. We're very happy that you guys spoke and we listened. We reach 4 million people a month, apparently. Or 3 million, I'm told. And that's pretty good on SkyTour Radio. And SkyTour LiveStream is the offshoot and companion stream to SkyTour Radio. SkyTour Radio is a fun... Oh, thank you, Amanda, for putting in the email. SkyTour Radio turned out to be a really fun little show because all the people you're hearing tonight are on SkyTour Radio. We have Daryl there. We have Amanda. Amanda's been my consistent co-host. And yes, and I'm there once in a while too, right? I think that as an astronomy show on a paranormal network, we weren't really sure it was going to go, how far it would go. But the KGRA leadership said, we want you to do this. We think it'll be a really good fit, believe it or not. And I think it's because we talk about extraterrestrial life in a scientific manner. And this is something that people really want to hear. So we're humbled by your attention and your love of science. We all love science. Amanda didn't know she loved science until she got into it. And now she can't get enough.
I just no, my poor math skills, I couldn't get very far in science, but now that I have someone that's, well, several people now,
that's right.
Daryl too.
Yeah, that's right.
People actually willing to give me the time I need to wrap my head around some concepts, and
yeah,
you know, I'm getting there.
Well, see, what you run into with me, and certainly I can't speak for Daryl, but I'm sure it's the same, is the fact that guys like me and Daryl too, apparently, we have infinite patience because we know that we were once in that position of not knowing a whole lot, and we asked all these crazy questions, as you might think they are, and only to find out, that we needed to get the answers too. Someone somewhere has to ask the questions, and why would I ever, and why would Daryl ever, he wouldn't, become so arrogant as to, find questions to be silly or stupid or crazy. It's no such thing. There's no stupid questions, ever.
Well, everyone's had to ask these questions at one point because we have answers for a lot of them, and
That's
how we
correct.
get answers. And you never know. It might be someone like me that makes a really important connection just
Yeah.
in my random thought processes.
Yeah, for sure. But still, it turns out that what we're doing, what Daryl, Amanda, and I do for everybody is we explore the universe and we hold it wide open for all of you to see. I look at it as the universe wants to be seen, and we are going to oblige it.
Nice.
So, in any case, folks, I want to thank you for coming along for the ride with us. I really enjoyed having you along. I'm sure that Amanda and Daryl did too.
Oh yeah.
Yeah,
Oh, yeah.
of course. And we shall return on the next clear night. So, from all of us to all of you, good night. And don't forget to keep looking up.
Night, everybody.
You're driving.
Except while you're driving. Good job, Amanda. All
Sorry,
right.
it's been so long.
I know.
Zoned out for a second.
It's also not SkyTour Radio. That's how we end SkyTour Radio. All right, folks. Yeah.
It's
Good.
late.
Good night, all. We'll talk to you another time when it's clear again.